Okay, welcome to Video4C, and hopefully we will be putting it all together and seeing some actual graphics flash across the screen. Actually, I'm in the debug context again, so get out of there, and let me go ahead and fix this so the name is actually being returned by our compile shader function. So, alright, so now we got our data bound. We've got our shaders ready to operate on said data. So now we've got to do the fun stuff. Alright, so as I said, old GL, you had the matrices were managed for you in the background. You don't have that anymore. So we got to set up our viewing matrices and our transform matrices. So matrix math. Alright, and this is where the GL mathematics library really makes your life easier. Now I just do 4. You see there's also a 4x4. I've actually looked into it. This is just an alias for the 4x4. So just FYI. Alright, so first one we're going to do is our perspective matrix. And like the old ortho command in that we used in some of our previous ones, this one works pretty much the same way. Now it's very important that these are templated classes, so if you don't specify the .0 or the .0f, it will make a matrix of integers, so when it tries to do the math, it'll be all whole numbers, and your matrix, you won't get a good display. Actually found that out the hard way earlier today. So, alright, so like the original one, oops, I'll just do this. So this is right, left, bottom, and top. So we're making a square here, the F. And then we're going to do our near Z plane and our far Z plane. Like I said, this is technically 3D, but we're putting 2D information on in our 3D plane, and we're pointing our camera at it. And so if you move anything in the Z, though, if you set those Z planes further and you move things along the Z plane, you will get no perspective. It will not get smaller, it will not get bigger. This is a orthographic projection. So, and I like to do this one just for the sake of it. So this goes ahead and sets the viewport to, or the view matrix I should say, to the identity matrix. So I like leaving it that way if we want to do anything special with it, we can. So, and then there's the model matrix. Again, I'm just going to go ahead and set that to the identity matrix. We're going to be messing with this a little bit in a bit, because this is where you would do your transforms, your scales, and your rotations. So this might change depending on what object you're working with in a real project. So, alright, and so now we've got that set up. I'm going to go ahead and leave this as is. Alright, so we are going to go ahead and start our graphics loop. So our loop's going to run for as long as the window is open. So as soon as we close it, this loop will end. And we're going to do our GLFW poll events, even though we aren't actually using any events that need to be polled. But this is where the callbacks for the keyboard, mouse events, and such would be called. I've played with that some. It's actually very quick and a lot more responsive than I originally thought it was going to be. So I'm going to go ahead and clear the screen. And I like doing this color originally. It used to be I would only do like a black screen and I just got tired of it. So now I do a kind of a bluish color. Oops. And though nobody's looking over my shoulder, I type like somebody is. Alright, so I'm going to go ahead. The first thing I'm going to do is get our MVP matrix. And I just realized I forgot to do something. So earlier I was talking about the uniform matrix, the uniform variables. And this one's actually you use a regular integer because a negative value will specify that a failure had occurred. And so I want this to be the location of the uniform variable that we specified in our shader. Actually, that's a different thing, isn't it? Alright, so we're specifying that from our shader program we want a reference to this variable. So we actually can use a string and it will give us a reference that we can use to populate this guy for all instances running. Now, another one of the odd things to have happen is if you call this and this variable is not actually used, the compiler will actually remove it as an optimization, because during my debugging I removed this from this call. So what would happen is the screen size would be, I believe it's just from 0 to 1, or the coordinate system would be 0 for 1, I should say. So while this guy existed in the code, because he had been removed from here, when the compiler had it, it optimized it out. So when I tried to get the location of it, here it returned a -1, indicating that it couldn't be found, which was driving me absolutely bonkers. So if you get a -1 and it's there, make sure it's used. Very important. Your sanity depends on it. Alright, so we're going to go ahead and make a variable, so that's P times V times M. And you'll notice it is backwards. This goes back to the matrix math conventions. So, interesting thing about matrix math, it does not have the, I believe it's the associative property of regular multiplication. So 1 times 2 is equal to 2 times 1, but P times V times M is not equal to M times V times P. So order of your matrices is very important. I often go to reference material on linear algebra to verify that I'm doing this in the correct order. So again, very, very important. Alright, so down here we're going to go GL bind vertex array, and that is actually going to put the card into, let's see, what did I name that guy? Is VAO. Alright. So we're going to just start with 0. So right now we have taken this vertex array object's name and bound it. So this is the one that's currently set in the card. Another important tip, we've got to go ahead and use, we've got to make sure that we tell it to use this program. So that is this. So now we have our array object bound, our program set. This is another one, another little error that kind of drove me crazy. So I want to actually now set the variable in the shader, or the uniform variable for the MVP matrix. So there are a multitude of functions for the different types. So you got vector functions, you've got longs, you got different ways of setting in arrays. So I'm going to suggest, if you want, depending on what kind of information you want to send to the shader, just go check the documentation. It's all pretty straightforward. So in this case, we need the location that we got from right here. And we're only going to do one. And I forgot what that does, I'm embarrassed to say. Oh, that's transpose. Okay, so that will, if that's true, that'll transpose your matrix. So if you're doing, I forgot if it was row major or column major, if you need to change it, that is where it will be done. And then we want to pass it along a array pointer to our MVP. So this will set the MVP uniform variable across all our shaders. So if you're going to send anything else, that is how you would do it. Alright, so GL uniform matrix. Now we can call our GL draw arrays, and we stored these as a series of points, but like the old style, you can do, let's see if it will just let me go there. No, it won't. But there's also GL triangles, GL polygons, all the different GL. This is a further way to tell it how to read your data. So 0, and we're going to tell it VAO 0, and tell it how many points there are with this particular VAO object. Then we want to set a then we're going to get our, make sure that no errors occur during the running of this loop. Actually, it's probably this way, yes. We're just going to go ahead and tell it to break out of the loop in this case. And I just did this, most of the programs I saw in various tutorials and such, they left the same vertex array object bound all the way through, which kind of made it hard for me to figure out what you could bind where and where you could release it. It's kind of like almost the brackets in a program. It was hard to see where the domains were. So I'm just doing this for the sake of showing where these can be bound and let go. Hopefully it would make that easier for other people to kind of emulate this in their own work if they wanted to do it this way. I saw a couple of Stack Overflow answers who were talking about how it's very inefficient to bind and unbind things. You should try and consolidate them into as many common locations as you can, which makes perfect sense, but I like knowing what I can do. Alright, and I'm just going to go ahead and add some GLF W destroy window. And if I were a smart person, there is actually a lot more cleanup. You want to clean up your buffers and your VAOs. I'm not going to do that here. Mostly I just wanted to show how they worked. So, but there is a lot of tutorials you can find out how to do that. Alright, so I'm going to go ahead and start it. I'm not expecting this to work exactly right to start with. Part of the reason for that is, if you remember, just a refresher, that the way we put these points in there were not integer, but whole x and y values, and our coordinate system, I happen to know off the top of my head that these images are 32 by 62 points. So our coordinate system is actually negative 25 to 25, so we're working with a 50 by 50 square, but it's projected in a 512 by 512 square. So that's, I think it was, actually I'll just do the math. So that's 512 divided by 50. So each coordinate, whole coordinate point is going to be 10.24 pixels across. So I expect it will be a dithered image. And I'm just going to go ahead and run it. And what did I forget? GL compile equals, oh, and that was a copy pasta error. So let's try that again. Really, I should have run that in between videos. I apologize. So you can see barely that we have some points that were drawn here, and they are really hard to see. But the image is there. The coordinates are just really spread out. At least I hope you can see it. I don't know how this is going to translate over to YouTube. So first thing we need to do is actually, I want to scale this back a little bit. Or actually, the first thing I'm going to do is just make those points visible. And I could probably come up with a way to make this dynamic based on the size of the screen and that, but for the sake of expediency, I'm just going to hard code this. So we're going to use GL enable, which is using one of the, if I'm not mistaken, I believe every time we use GL enable, we are using one of the fixed function shaders. So we're going to say, go ahead and enable us to select the point size, and we are going to go ahead and set the point size to, I think we said it was 10.1. I believe that's correct. So that should fill that out such that 1 pixel is going to be what we would more expect it to be. Now, this is probably making a liar out of me when I said that the vertex and the fragment shaders have a one-to-one relationship. I believe what's happening here is this, in the geometry shader, will actually tell it to generate more fragments per point around the outside. Now, that's a guess on my part. I don't know that for a fact, but I'm going to go ahead and build it, or run it. And you see, yes indeed. Now he's a little closer. Let me go ahead and make that a little bit bigger, and I think you can see who I'm making here. Oops. And you've got to make sure to close him, or else the executable won't get overwritten. So I will just say I undertook this project originally not because of the shader reason I gave earlier, but because I've been very interested in doing 2D pixel graphics. Okay, I'm going to call that good enough. So he is a little big. I want to shrink him down. Now, in the past, what I have done is I have gone into the data and added a multiplier, so when it was stored to the buffer, I would multiply it by half. But now that I know a little more than I did, I want to make the graphics card do that for me. So I'm going to go ahead and scale it, and I'm going to use a GLM function. Alright, so GLM vec3, and like I said, I want to shrink him down by half so he will fit on the screen. So 5, so we want to shrink it X, Y, and so now when we do our PVM, it's going to multiply every point by half, so it will actually pull them together. And when we do that, we don't want, we're no longer going to have 10 pixels per point, so I'm going to go ahead and reduce this down by, actually he was a little broken up, so I'm going to go ahead and leave that like that. That should cement him up just a little bit better. So, right, so we made him a little bit smaller. He's still got a little bit of breakup. So I'm going to go ahead and put that back there, and hopefully, let's see, that's closed, that's closed. So hopefully now he will not have those little artifact lines in him. And he still does. So increase it to 5.5. And I probably shouldn't get hung up on this because I've only got so much time per video. But alright, so now he looks whole. And I'm just going to go ahead and leave him like that. And I wanted to show one more thing that just for fun. So now we've got a working shader program that is taking our buffer data and is putting it to the screen. So the one more thing I'm going to do just for fun is I've got 3 buffers, so I'm going to go make it so I can switch in between them. And to do this, I want timing. And another great way to do timing is the, let's see, the Chrono library, which I believe that was introduced with C++11, and I positively have, I love the way it works. And so you have to use auto a lot with the Chrono, I found, because these data types get, you can see they get pretty long, and some of them just get insane. And I'm pretty much copying and pasting this from some code I wrote earlier because I just wanted to show this one thing because I thought it was cool. Alright. And I was using Chrono earlier to count the number of milliseconds per frame. Alright, so this gives us our when everything started, and this will give us the difference for between when everything started and what now is, and we can get that value back in milliseconds. So we can count the number of milliseconds between frame rates. So one of the things that, see, I'm mostly a business software app developer by trade, so one of the things that I really had to wrap my mind around is when you're doing graphics, you've got each iteration of this while loop is one frame. So all of your drawing code, all of your update code has to be in here, and you want it to get through this as fast as is humanly possible. Let's see, I also need a state variable. So this guy is going to indicate which state or which array buffer we're using at which time. So, and from here we need to reset ms start. Alright, so when we are more than 50 milliseconds, ink the state, reset the clock, and it is 3. We only have 3 states, so this will indicate it's in its 4th state. So we're going to reset the state to 0. So every time this occurs and it's been more than 50 milliseconds, it should ink to the next state. And the state controls which VAO is being drawn, so let's see how it works. And here we have running Mario. Now you can do other things. I was playing around with this guy earlier, and you know what, just for the sake of it, I do not hold the copyright on Mario. This is just for entertainment and educational purposes, just in case. I'll actually put a link to where I got the sprites for this guy. I just wanted to use some well-known pixel art because it looked good and it was cool. So I'm going to say, see, I actually forgot what I was going to say. But thank you for your time. I hope this helped out anybody who's trying to learn more about how to use modern GL shaders. I've actually also been doing some stuff with texture mapping. I might be doing that next. I have a texture mapped version of Mario that I don't like nearly as much because it tries to do a lot of dithering, so you don't get this nice sharp sharp points that you see here. And it's pixel art, so you really want to see the edges, I think. Oh, now I remember what I was thinking. So if you wanted to make him move around, to make him jump, to do things like that, you could control the size, the transform, the rotation by modifying the model matrix. And because you can update the model matrix every iteration of the game loop, then and he gets passed along to the uniform variable, you can make all sorts of changes to how the shader is going to work on that data. The modern GL is really powerful. I've actually looked at the 4.2 and the 4.5. The API just seems to be getting stronger and stronger. Again, I hope everybody enjoyed this. I hope it was useful. If so, please give me a comment, tell me what you liked, tell me what you didn't like. Thank you for your time. You guys all have a good night.